My name is Francisco Menezes, and I work in the expert team as one of the lead architects. And I've been working with OutSystems for the last 14 years, so a lifetime, where I did all kind of roles in services. And since 2012, I've been helping customers to integrate OutSystems in their ecosystems, to design the architecture, and so leveraging the platform and trying to find the best fit of the platform on an existing ecosystem. The goal of this session is to show how to build a flexible and cost-effective solution architecture. And when I say cost-effective, it's something that is easy to maintain, is easy to evolve, but fully aligned with the business concept. So the main goal is not to just create a technical architecture, but something that actually represents the business concepts and the business strategy. In order to support the architecture design process, in OutSystems, we have a framework which we call the 4-layer canvas, and which is basically a concept. And that's what I'm going to explain, the concept of the 4-layer canvas. So the idea behind the 4-layer canvas is to help designing an architecture, and not only to help when we already know exactly what we want to build, but also to help supporting on the discover phase where we are still disclosing the requirements and the concepts. And this is a 4-layer architecture, which means that we are going to, everything that we build, every type of module that we build, we will try to fit in one of these layers. Let me just stress here that we are not saying that architectures are limited to 4 layers, but we are classifying everything in 4 layers because even inside each layer you can have several sub-layers. But the main idea, and to simplify the model, is that we need to classify everything in these 4 layers. Let's explain what are these layers for. So basically, this is going to support the design of a service-oriented architecture. So first of all, we have an area, the top 2 layers, that's where we are going to develop stuff that are not services. It's not meant to be to share information or to be reused. And on the bottom 2 layers, that's where we are going to build the reusable services. Okay, let's see what are no services. So in the top layers, we have the orchestration modules and the end user modules. Let me start by the end user modules because it's easier to understand. The end user modules, it's everything that is going to support user interaction. We will support all the UI to provide functionality to end users. The orchestration modules are basically top modules that will orchestrate several applications. For instance, an access portal where you have a single entry point and then you can interact with several applications, okay? Or for example, if you need to do some global dashboard to show you numbers about the behavior of different applications, this orchestration module will be on top of all the applications. So here we are providing users with end user functionality, and we are not providing reusable services. So everything that we do is supported by reusable services on the bottom 2 layers, where you have both business or business logic or non-functional logic. So the business services, these are services around business concepts. And I stress again the business concept because we want to reach an architecture that is based on business concepts, not simply on layers or technical structures. So everything that evolves around a business concept, like a customer, a contract, a billing, whatever, we build logic around that concept that can be reused in different applications. So we are promoting a service-oriented architecture where now you can have different end-user applications reusing the same common knowledge, same common code. To support the business services, we also need to rely on non-functional requirements. That would be like integration services to external systems, any kind of non-functional requirements like a Google Map, some nice UI widgets like a calendar or an accordion, all those kind of reusable widgets that are not connected to a business concept, but they are enlarging your infrastructure and you build on top of it. And I mentioned integration services because sometimes when we build a business service, we need to integrate with an external system. And at the library level, that's where we put the integration code, which is not bound to business concept, but it's bound to technical integrations, how to get there, what is the protocol, how to map the structure of the information from the external system to the internal application. Okay, so the concept of the 4-layer canvas, so it's easy, only 4 layers, and you just have to keep in mind that reusable services are only on the bottom one or bottom layers. This will be key to design and also to validate an architecture, because it's very easy to start providing functionality at the end user modules or orchestration module if you don't pay attention to this division, and you will understand why this is important. So basically, the use of the canvas speeds up the architecture design with a systematic approach, so you know exactly how to attack a new design, and also it's a systematic approach for the developers, for the development phase as well, because every time you need to build something, you know where to structure. Is this something related to end user UI? Is this related to a reusable business concept, or is this related to a non-functional requirement? Those sort of things. The other benefit is a common understanding. The minute you start using these concepts among your developers and even with your business users, it's much easier to communicate. Finally, it becomes very easy to validate an architecture, even supported. This is supported by a tool. I will mention the tool later, but it's the discovery tool, because now everything is well structured, and it can be automatically validated. Okay, so let me give you an idea how very global idea how OutSystems fits into an enterprise ecosystem. Of course, I'm putting the big picture of an enterprise ecosystem, but if you're just working in OutSystems and OutSystems is not connecting to anything, we just need to ignore the external system, but the architecture is the same. But basically, what I'm showing here is the services. So either business services or non-functional requirements, so the libraries or core modules. This is the layer where we are building the services, and on top of the services, we have these OutSystems applications. At this level, we can also provide microsites to be incorporated into an external portal. Now, the services themselves, they can either provide APIs to the external world, so we expose some API that can be consumed by external consumers, or this service will extend existing system of records, either through corporate databases or through external system of records that we need to connect with. So next, I'm going to show how to detail these services, how to structure these services. By the way, even if we are communicating with all the external systems through an enterprise service bus, this doesn't change the architecture. The only thing that changes is that we will always communicate with enterprise service bus, not directly to the external producer or consumer, but the principle is the same. Okay, so now I'm just showing the services part. So the services will be consumed by OutSystems applications or by an external consumer. And the service itself is layered in three levels. So you have the service itself. So we can have a service around the business concept of a contract, a customer, an order, a product, whatever. But these are system agnostic. So I don't want to build a logic here that depends on external systems, the way I need to expose this to external consumers or the way I consume it from external producers. So basically, the idea is to have two extra layers, one to expose APIs to the external world and another one to integrate with the external world. What are the benefits here? At these layers, these are simply technical wrappers where you don't add any business logic. We can instantiate these APIs in different ways, either because we need to provide two different APIs because we have two different consumers, external consumers that require certain signatures or whatever. But these mappings between what we need to provide to the outside world and what is the internal representation is captured at this layer. So we provide some API or some method, and we receive some input, and we transform this input into our internal representation, and then we call the internal service. So the internal service does not need to be aware of the external consumer. So it will be protected from that system that can change and or can be upgraded or can be replaced by something else, and maybe we need to adapt to the API, but it's completely separated. Another kind of thing that the API may need to handle is the type of protocol. Is this a REST, is this SOAP, or even maybe it's a FTP call that will send the files, whatever. But this is the protocols, all the authorization mechanisms and security and so on and so forth. It's dealt at this layer. Of course, the OutSystems consumers, the OutSystems applications can hook directly into the core service, leveraging all the platform capabilities. Because of course it's much better to hook into the service itself, because then you can use entities, you can reuse web logs, all kind of things that you cannot expose in a REST API. But at the end of the day, the logic that is run either by an OutSystems consumer or an external consumer is common, is always the same, because at this level, this is just a technical wrapper. The same goes into this level. So here, for instance, the concept of an order, the master of records of orders may be external systems, even it could be in one external system, but complemented with extra information in another external systems, but we don't need to know where this comes from, because that's the objective of the integration service. The integration service will map every internal representation of these systems into our own representation, and will handle all the protocols. Again, this is not the place to put business logic, just the technical wrapper to the external system. Okay? So, having this in mind, that we always try to isolate the core service itself into something that is system agnostic, and we might have to add an external API if we need to expose to the external world, or we might need to create an integration service if we need to consume information from an external system of records. Let me now introduce some typical patterns for building this kind of core services. So we have the first pattern, which is an external core service, and I'm calling this external core service because the concept in this example, the concept of a customer is actually represented in an external system. This is the master of the customers. Okay? So the normal pattern is that I just add an integration service, and then I create my extended logic or my own extended business rules at my customer core service. The consumers of the customer core service, they don't need to know about external systems. They just consume this system. If I replace this by another system, as long as I remap and all the API to the new system, this is invisible or is transparent for the core service itself or the consumers of this core service. The second pattern is when, even though the system of records is external, the master of the records is external, I might want to have a local replica. So this is an external core service with a local replica. Why should I need a local replica? Well, there are several reasons. One of them might be performance, because I don't want my applications, every time they are fetching data, to bang the external system. There might be some latency to get to that system, so we can do a replica. In this kind of pattern, we will have a timer, a batch process to replicate the data or any other kind of asynchronous process that will ensure that we get a replica here. Of course, there are several strategies. Sometimes it's not the timer is on demand. The minute I try to get information about the customer, if it's not on my local cache, on my local replica, I will have to fetch the data for that customer, and we might have all kind of policies to update the information or check the information is updated. I'm not getting into complex details here, but the idea is to grab here is that sometimes it's very beneficial to replicate data here, not just to avoid latency to get to the external system, and also protect external systems from a massive number of calls because we are exposing these into an application that is in the internet, but also because if we have a local replica, we have a database model inside OutSystems, then we can benefit from that. As you might know, if you're already using OutSystems, every time I consume this kind of services, one of the APIs might be the entities themselves. So if I can consume an exposed entity, I can do a lot of scaffolding to build a screen. I can use the OutSystems aggregates to mesh up information from different tables. So these will also benefit the rapid application development in OutSystems. Another pattern, which is the same, but now we are isolating the synchronization logic. Sometimes the synchronization logic is complex. And again, because we are always trying to abstract things, the core service itself does not need to know about the synchronization logic. And another benefit is the fact that the consumers of the core service, they need to consume the core service itself, not the synchronization logic. So by having the synchronization logic separated, it means that this component gets slimmer, and which means that all the consumers of this component will also inherit less code, so they will have a smaller footprint, and they are not impacted by changes on the synchronization process, because mainly when we are starting a new project, we will find some bottlenecks, some performance issues. We need to change the policy, how we are synchronizing stuff, and we can change these, and these are not impacting the service itself. So the synchronization process consumes the core service because it needs to put stuff in there. And so it's going to fetch data through the integration services, and is going to place information on the core service, but it's completely separated. So it's a good idea to separate the synchronization logic whenever you start getting a complex synchronization process. The next pattern is yet another variation where, and let me just start by saying that all these customer core services are seen the same way by the consuming applications. They just see a local service. They don't care about what is behind, if it's synchronizing and how it's synchronizing, and if it's only one system. And we have another situation where we need to synchronize with several systems. For instance, maybe depending on the type of customer, if it's a corporate customer, it will come from a certain ERP. If it's a home customer, it will come from another place, or just by region, depending on the region of the customer, you may have to find customers in different systems. And so you will need an integration service for each one, but the customer sync is the one that knows how to fetch data from different systems and place them already normalized on the local replica, okay? There are a few other variations. I'm going to show you a link at the end of the presentation that you can follow to find out more. I'm just trying to cover the main concepts, otherwise this would be a very extensive session. But these are the most used patterns for implementing the services. Okay, so I introduced the concept of the canvas, the use of the 4 layers, which is basically a classification of modules depending on the purpose, if it's providing a service or not, and if it's providing a service, if it's business related or not, and if it's an end user process or end user module, you might have the application components themselves and plus the orchestration, which typically means that you need to orchestrate several applications into a single portal, into a unified dashboard and stuff like that. Now, let's focus on how to achieve an application from scratch, an architecture from scratch when we need to solve a new problem. And of course, this is also useful to understand what needs to be fixed on an existing architecture to make sure that it's properly layered. And the benefits of this layering will become obvious in the next slides. So the process is composed by 3 steps, and I'm formally introducing 3 steps. Of course, this is something that once you understand the steps, it becomes natural, and you stop thinking about steps. You're just doing it naturally, and you iterate among these steps. So these are the 3 steps. You have one phase where you disclose information. You have a second phase that you organize the concepts. This is not still, it's not yet the architecture, it's just concepts. I mean, when I say architecture, it's not modules that you need to build, it's just concepts. And then you need to assemble these concepts into modules following some patterns, okay? And we can use the canvas in this process because even if we are in the discover phase, we can use the 4 layers to drop the concepts and start organizing them. So let's see. The first step, we are going to disclose business concepts and all integration needs or all non-functional requirements, like we need to audit everything that the user is doing, all kind of non-functional requirements. This is typically done either because you're talking with the business owner or the business analyst, or because you're looking at user stories and you start getting concepts, or there is already an information architecture with the business concepts already identified and the hierarchy of concepts. And actually, the information architecture is normally a good starting point to get concepts because these are not bound to technical stuff. It's bound to the business language. So we can start getting a lot of concepts from the information architecture. By knowing the integration technology in your ecosystems, you will find what are the integration needs that you will require, and also knowing what are the UX expectations for the solution that you are going to build, because that can also influence the architecture. So after we disclose the concepts, we can start organizing them. And of course, this is an iterative process. I can keep disclosing stuff and keep organizing in the canvas. So basically, at this point, I'm not thinking about architecture yet. I'm just organizing concepts. But I already think of concepts in a structured way. For instance, at the lower level, I get all the integration needs and non-functional requirements. I need to integrate with this ERP, with that CRM. I need to audit everything. I need to build some access list control for my application. So these are the non-functional or integration needs. And then you also start hearing about concepts. Okay, I have the concept of a customer, of a claim, of a contract, of a product, and those I just place them at the core business layer. I also listen or hear about processes that need to be performed by users. I need to do customer management. I need to do claim handling. I need analytics to analyze my process, so on and so forth. Finally, we also understand the needs for access portals. If we are not talking about a single application, but a constellation of applications, and we need to create a site for the public, a call center access portal for everything that the call center needs to support their activities, a back office, so on and so forth. So these are examples. But the main idea here is that with the canvas, I structure my thinking in these 4 levels, and I can collect, disclose information, and start placing them in these layers. Okay? So again, just to recap, this is the orchestration layer, this is the end user layer, this is core business layer, and this is the libraries. And at this point, I'm not thinking about modules, but I'm placing the concepts, okay? And you may end up with thousands of concepts. It doesn't mean that you need to build thousands of modules. That's the next step. On the next step, we need to assemble these concepts, matching some recommended patterns and understanding the nature of the concepts, how they can live together or not, if it makes sense to be together or not, if they are completely independent of each other, they can have different life cycles, and all those kind of considerations. I'm going to do an exercise just to show this. And of course, here we can now try to decide using some patterns what we need to build and throw it into the canvas now in form of modules that need to be built. Okay, so to recap, we discuss, we organize concepts, and then once we have all the concepts organized, we can start assembling and matching concepts into modules. Okay, so let's follow an example to illustrate what I'm talking about. So let's imagine that we are following a process of designing something new. We are still in the discover phase, and let's iterate between step 1 and 2. So we keep disclosing when we keep organizing concepts. So maybe first of all, I hear that we are going to create an application to assist on the recall process. Okay. Well, even if you don't know what's the recall process, it's not very important. But let's imagine there is a process that we need to help someone to build. But just to summarize, this is a process to help a store owner to understand what are the products that need to be recollected because they are they represent a danger to public health, or they are outdated, or whatever. And as we discuss this process, we learned that we need to deal with stocks, products, stores, product families, suppliers, recall plans, because we need to plan some recall process. We need to plan it because there will be several people involved. So without worrying about understanding this specific problem, the question is that on the process of understanding what we need to build, what is the solution, we learn that we need to this user process to support people to do the recall process, and we need to deal with products, stock of products, stores, suppliers, recall plans, etc., etc. We also learned that products are already maintained in an external ERP connector. So this is an integration need that I'm just collecting here the concept. I will need to integrate with that ERP connector. And we keep disclosing, organizing. So next we learned that we also need to audit the suppliers, because those are the ones supplying the products that may be malfunctioning, or they need to be involved in the recollection of the products. So there's another process. And while we are understanding this process, we understand that it will need these concepts plus some extra concepts. So we keep adding those concepts, like a supplier audit, a supplier report, a supplier audit plan, and so on and so forth. And we may learn that now we also need an internal portal for my internal users and a supplier portal, because they will be interacting with us. And this is another need that I'm collecting. So I will need to access portals. And then I also understand that these portals will have different look and feel. So I will need teams, to domain teams, one for the suppliers and another one for the internal users. Okay, this is a very simplified problem. In a real problem, you might end up with much more concepts, but I don't want to complexify too much this example. And so let's work with this. So how do I proceed to the next level? Now that I finished disclosing everything, by the way, when I say I finished, it doesn't mean that I need to finish here, because architecture is something that is a living process, because the solution itself will evolve. So you will keep disclosing, organizing, and even modeling after the initial design. So it's a continuous process, right? But the next thing I need to understand is, do I need a module for each one of these concepts? How they should be merged together, or all kind of considerations? And of course, then I will need to understand, okay, so this is coming from the outside system records. Do I need to have a local replica, and all those kind of considerations? So let's look at this example. And basically, what I've done here is, there are these two concepts. They are unbreakable. I cannot have product families without products. And actually, these are so related that every time I change a product, I also need to add some product family functionality. So I'm merging these concepts into one. In this example, these are base concepts in the sense that they will be useful strategically. We also need to identify if are the concepts in the core of this company, in the sense that, okay, this company deals with stock, so there will be other applications that will deal with stock. So I'm already saying that I need to keep these basic concepts as the base for other stuff. And for instance, these three concepts here that we identified before, these are process support concepts, because these are concepts that will support the supplier audit process only. So we know that strategically, this is not something that to be reused everywhere, but only by this process. So they are correlated, and I'm putting everything together. And as I mentioned before, this is a very simplified problem, and I'm not even now representing here the patterns that I explained before, the fact that we need to put synchronization process on top, or we need to expose an API. So basically, what the result here is that these are the services that I'm going to build. So I have this base service, store service, supplier service, stock service, product service. Then I have the supplier audit service, because this is to support the supplier audit, the recall service to support this one. And of course, here I changed the ERP integration node by a product integration service, because I don't want to be strongly tightly connected to that ERP itself. So I'm saying that I need an abstraction here to get products. So it's the product integration service from outside. So even if tomorrow I change the ERP, as long as I keep these, everything can be reused. So the idea of not putting the name of the system here, because I don't want to make this architecture strongly connected to that specific external system. Okay. So this could be our final 4-layer architecture for this solution. Okay, so let's see what else. What are the benefits of this kind of architecture? One of the benefits is the fact that I absolutely sure where are the services, and so these modules, they may be very complex, but they have no responsibility to expose services, so they may be as complex as they want. While these services, they have to be carefully abstracted and carefully isolated. Okay. Well, one of the benefits is that, of course, you have much more granularity. This tends to be smaller and much more granular. So there you keep creating building blocks that can be reused on the other layers. And of course, the top 2 layers, they are not supposed to be reused. So this you can read here as 0, 0 reuse. But on the bottom 2 layers, you have high reusability of library modules and medium reusability on the core business modules. Of course, information hiding is another benefit, because the abstraction that you are forced to build in such a service-oriented architecture means that now you can rely on abstracted building blocks, and when you're building your end-user processes, you don't need to know what's inside. You just need to know how to use the service. And the service is hiding all the complexity, even from external systems, because you also have these abstractions of the integration services. So there's much more abstraction, of course, and the abstraction is higher on the bottom layer. You gain a lot of mesh-up capacity, because you're building services that now can be meshed up, and you can compose information on your business processes. Sorry. And in overall, you will have much more control and autonomy everywhere, because now you can even have different developers developing different stuff, different layers, or with different specializations, because for any end-user module, it has to do much more with user interfaces. So maybe it's someone that is more acquainted with nice interfaces, while the guys in the integration layers or the library core, maybe you may have someone more into advanced SQL to build complex stuff and so on, or other kind of things. But you have autonomy in the sense that the limits, the boundaries are well set, and you can work in each layer without depending too much on the insights of the other components. Okay. So now that I've introduced the concepts of the 4-layer canvas, I've shown you an example how to build or how to come up with a design for a solution where you identify all your end user process, or all your core concepts, all your integration needs, non-functional requirements, so on and so forth. You grab all those concepts and you come up with an architecture. Let me talk about how to validate architecture. And when I say validate architecture, either because you designed the architecture from scratch, and now you need to make sure that you keep evolving correctly, And because it's also important to understand that sometimes it's so easy to commit a violation. For instance, I said that an end user module should not supply services, but a developer could very easily reference something or expose something inadvertently, or because he does not have the full concepts fully embedded in his brain. So we need to keep validating if there are no violations to the principles, okay? And so far, I introduced 4 layers, and now I'm going to introduce 3 rules, and that's the Canvas process: 4 layers and 3 rules. So, what are the validation rules? The first rule is that you should not have upward references, which is intuitive. So it makes no sense that a library module, which is non-functional, depends on a functional core module, or depends on end user interfaces or end user processes. The same goes from a core module should not handle something above. So conceptually, this makes sense. But also technically, this has very significant importance on what you're building to avoid spaghetti implementations and also to avoid complex deployments. Let me show you what happens if I do an upward reference. So let's start by a few modules. I have here 2 end user modules, 2 core modules, a library, and this is correctly, the dependencies are correctly set. So I don't have upward references. The modules are consuming something below. But if for some reason I leave an upward reference, what happens is that now I created a cluster of modules that indirectly they all depend on each other. I can pick any module here. For instance, from this one I can reach this one, and from this one I can reach back the first one. So there is a loop between any 2 modules that you pick inside this cluster. Okay? What is the problem about this is, for instance, you will have a huge impact on another consumer. So this guy thinks that he's just consuming this service, but he's actually inheriting a full-blown application just because there was an upward reference. Okay, so this will highly compromise the life cycle of your applications, because you don't want this kind of dependencies. You want to make sure that if I want to deploy this application, I don't need to be dependent on that one. Maybe that one is not even ready to go to production. So the life cycle, the dependency between modules are highly compromised by this upward reference. Actually, the upward references are the worst references ever, because they introduce a lot of cycles. And then you end up in a situation where every time you change something, the system keeps complaining that all the consumers are outdated, and you enter and refresh references nightmare, because there is this big interconnected graph of modules. Okay. The second rule is related to the fact that I don't want to expose services in the top 2 layers. So if I'm not exposing anything, they should not have side references. For instance, if I have this correctly layered architecture, and now I do some reference from this end user to that end user, it means that this one is exposing something. So you can read as is exposing a service that is reusable by this one. And maybe this is something as simple as something just a function to format special format of a string or something that has been implemented here, and now I'm in a second project. Oh, let me reuse that. Immediately, I created another violation, because now I have one application depending on another one and inheriting, because these are in the top of the 3. The end user modules or the orchestration modules, they are in the top. It means that they will drag a lot of indirect references with them. Okay, so this is let's say the second most dangerous reference violation. Finally, because at the bottom layers we can have side references, so this restriction of not having site reference is only at the top two layers. But because I can do it in the bottom layers, I just need to make sure that I don't have cycles, okay? So let me just stress this, because people tend to think that cycles is the worst. But the upward references, it's also creating a cycle. And it's probably creating one upward reference typically creates tens of cycles, indirect cycles. While if you have just two car modules in a cycle, like car module A references car module B and car module B references car module A back, it's only two modules that are involved. So that's why upward references are much more dangerous, because they tend to create a lot of cycles, okay? Okay, so these are basically the rules. I have just a few side recommendations that the core modules should not have front-end screens. They may supply reusable UI snippets like web blocks that can be reused, but this is not the place to supply screens. It should have only read-only entities, and read-only means it can expose entities, but they should be set as read-only, so the consuming modules cannot start creating stuff in a ad hoc way, because you need to control all the creation. It's good to expose an entity because we leverage the capability of the platform to scaffold a new screen and to aggregate information, so on and so forth. But all the transactions and the creations and updates should be controlled by the core module. And finally, at the library level, you should not have business logic nor core entities. You can have entities, but these should be auxiliary entities, not like, let's say, if there's a library and you have the customer entity in here, customer is a core concept. But if you have a library like a Google Map and you have a point entity just to mark to save points that you want to record for later, that's something it's not the core of the business, right? So you might have entities, but as long as they are not core entities, okay? So let me introduce you to Discovery. The Discovery is a tool that you can fetch from the Forge, the OutSystems Forge. I also included a link to Discovery, so later on, if you collect the slide deck, you will have that link. And the Discovery, I'm not going to do a full presentation of the Discovery, but just highlight the major things. The major things that I've been talking about modules, right? And a module architecture. Later on, I will also talk about applications and application architecture. But at module level, I can actually check the composition of my application, see the layers of my application. I can select what is the application I'm looking for. And at this tool, you can, the help will give you a comprehensive explanation about the layers and the type of evaluation. So this is just to recap the concepts, right? How do you use this tool? First of all, you need to classify the modules. So the first time you're analyzing a new project, you will need to identify is this a core, end user, a library, an orchestration. You have to identify this and place in the proper level. The main things to do here is to make sure that you start by the top categories, in the sense, if it's supplying screens, it's an end user. Even if it's also supplying services and exposing entities, I don't care. But I try to classify first, if it's something that is orchestrating several end users, I try to put it as an orchestrator. If it's exposing user interfaces and user processes, it's an end user. And then you classify everything else that is only exposing business concepts as a core, and everything else is a library, okay? This is important. Why? Because the correct identification of the level of the layer, it's important to get the correct insights from the discovery, the correct recommendations, and the correct validation, okay? So once you have everything classified, you can now, for instance, let's look at this module, which is the Agile Management module, and this is an end user. And I don't see any, for example, in this example, I don't see any orchestration module. So who is consuming it? This is obviously an evidence that something is wrong. And if I click on this number to see the consumer, I see that it's being consumed by two other end user modules and a core module, and I can actually see what is being consumed. Okay, I'm going to open the discovery tool next, but let me just explain the concept here. And I can even see that there are 15 exposed elements that are being consumed by other modules. And I can even filter if I only want to see what project site reports is consuming. I can click here and it will show, for instance, this is showing that everyone, all the 3 consumers are consuming it. This is being consumed only by 1, so on and so forth. This gives me a lot of important information. For instance, it's telling me what kind of service this end user module is providing that it should not. One thing that becomes obvious is that this is the one providing the style guide, because you see the style guide here, the theme. You see the theme here, and so everyone else is using the theme, the headers, the menu. So these are all style stuff, style guide related stuff. So this is obviously something that should be removed from this one, and we should create a specific library just to contain the style guide. Okay. What else do I learn here? There is also a concept of issue feedback that is being provided by this one. You have the concept of an active project. Just one second. I'm sorry. I need to drink a little bit of water. Okay. I think I'm getting my voice back to business. Okay, so by looking at these elements, I can infer what are the services that are being provided. And I clearly need to isolate the theme, and maybe I need to place these generic concepts in another module. Okay, this is just an example. What else can you do? You can even inspect a violation itself. For instance, there is upward violations from this core module, and then by clicking here, you learn that it's referencing Agile Management, the one that I just showed you. So it's the same conclusion. I'm using the theme from the Agile Management. And it's also reusing concepts from project site, which is another end user module. So again, project site should not be providing this service. Okay, so you can either analyze, like I showed here, who is consuming and what is the service that is being consumed that should not be here, or you can analyze each violation to understand a certain violation. Of course, if you have like a cycle, you want to know the details about that cycle, and so on and so forth. So you can actually use the discovery to find a lot of stuff. Let me quickly show you. I'm sorry, I have to escape this one. For instance, this is a real use case scenario where I'm just looking at one application. The first thing that you immediately learn at this application is huge. It probably should be split in different applications. That's something that I'm going to discuss next. And it has a lot of violations. And something that becomes obvious is that a lot of services are being provided by these end user modules, because there are a lot of side references, there are upward references, and actually, in this case, it's difficult to change something without impacting everything else. Every time we change something, you need to refresh consumers, but then if you refresh consumers, there will be consumers of that consumer that need to refresh. And actually, this means that the runtime code that is going to be produced is always very fast, because every module will need the code of almost every other modules, right? And this can impact even the performance of the application, because you will be using a lot of resources from your servers. So your application pools need to be large enough to contain these huge modules, because each module is a very fat module. For instance, if this core consumes something from above, the module itself will contain a lot of code from the the modules that is consuming plus indirectly all the modules that the others are consuming. So this becomes a nightmare. Okay. Now, one thing that you can do is to sort, because this is sorted simply by alphabetic order. You can sort by relevance, and when you sort by relevance, let me show. Oops, I'm sorry. I guess I was locked here for a long time. So when I sort by relevance, you can see that this is the module with more impact. Why? Because it's being consumed by 29 modules, and it itself is consuming 15 others. So this guy is introducing a lot of connectivity in the references among modules, right? So I might want to see why everyone needs so many references to this module. So I understand that, okay, this is an end user, but that's where you're implementing a lot of concepts. You have the concept of a connection meter, connections, connection meter, requests, and so on and so forth. So this is basically a sign that we should have isolated this concept in reusable core services. Okay, so sometimes it's only one concept that you need to extract and create only one core service from that one. Sometimes it's several concepts that you need to spread in different modules, unless they are related with each other. But I'm showing an example which already shows a lot of complexity because the architecture evolved without this type of cares. Of course, there's a long theme that we could be discussing, refactoring an application. We don't have space in this section for this, but as a reference, you should check also a refactor component in the Forge that helps you refactoring your architecture when you find that you need to move elements around. Okay, so I gave you an overall idea. Of course, I could also see what are the violations of a certain module, and this one has a lot of violations. It's consuming stuff from this module and something else from another. So actually, this is a consequence of the end user modules providing services. So basically, when you want to refactor, you should start by solving the services that are being exposed first in the portal. So this portal is okay, it's not exposing anything. Then you should start solving removing services that are being exposed in each end user module. So after doing that, then you can start fixing the cycles at this level, because the cycles here are much more contained. They don't drag a lot of so much modules with those references. And finally, solve the problems, the loops between the libraries. Okay, but by extracting the services from these guys from the end user modules, you will fix all these upward references, which are the most dangerous ones. Okay, so let me go back to the presentation. I was just trying to show you that there is an assisted way to check the architecture and to check what is wrong, to get some hints, what are the unwanted references that are creating the problems, and that will be the discovery tool. Okay, I'll be back to discovery tool after we discuss the application architecture. Well, so far I've been talking about modules. Individual modules, they can reference each other, they can expose or not services, and there are some patterns. I've shown you some patterns, not all. You can refer to the full article that is provided at the end of the presentation for understanding more patterns. But now we also need to consider the applications, because an application is a set of modules, and there is also an architecture for applications, not just for the individual modules, but for the application itself. So I'm going to talk about 4 rules for composing lifetime applications And when I say lifetime, just to make sure what is an application year, because there's some confusion between what is perceived as an application and what is an application in OutSystems. An application in OutSystems is a set of modules that you combine and that you can version, and that it's the minimum deployment unit that you can deploy across development, quality, production using lifetime, okay? But these are the rules that will minimize impacts between applications, simplify the deployments, and cope with different paces, different life cycles, and so on of your modules. So, as I explained before, an application is a set of modules defined in service that constitutes the minimal deployment unit for lifetime. And the good news about applications is that once you understand the 4 layers and the violations, everything applies here. It's exactly the same concept. So what is the application layer? Is the layer of the topmost module. So I've shown you before that when you have modules, you have to classify the layer for each module. Here, since we have applications, they simply inherit the classification inside. So for instance, in this example, I have one orchestration to end user and a core, but the top is an orchestration, so the whole application is orchestration. Here, the whole application is an end user because the top is an end user. Here, the whole application is a core because top is a core, so on and so forth. So this, the classification, you don't need to worry about it because you already did it in the core level, in the module level, sorry. So how should you compose your application? First of all, the first rule is to correctly layer your modules. So this is what I explained before about the module architecture. Meaning that if you have a lot of violations at module level, it will probably be very difficult to avoid violations at the application level, right? Sometimes the module applications the module violations don't influence the application if they are just internal to the application, so they will not extrapolate to other applications. But most of the times, if you have an upward reference to something that is generic outside your application, you're already dragging at the application level. You're already creating the wrong references. So the first rule is you need to have a correct layered module architecture. Now, the second rule is that you also need to layer your applications. So what happens is that normally when you start a project, you will end up with a set of modules. So this is your first project, and you followed all the rules, so you have a correctly layered module applications. But of course, you need to deploy these, and actually, as you build these modules, you will probably create one application just to contain everything. And that's the application that you will now, this is the first project you will deploy, right? You are not worried about creating different applications, just one. It's just a bag where you put everything of your project that now can be deployed together. If you have a second project with similar properties, you will end up having a second application, end user application. Now, after having these, you can start evolving, and because you have reusable services at the core and library level, at a certain point in the third project, you start referencing these core services because they are meant to be reusable, right? So there's nothing wrong at the module architecture, but what happened to the application composition? Now you have this application consuming the second one and the second one consuming the first one. So is an example. This is an example actually of a side reference because this is an end user application consuming another end user application, so it's a side reference. And in this case, it's also an example of a cycle because they reference each other. So the idea is always to, as the same way at the module level, we said we cannot provide services, reusable services. At this level, we cannot put reusable services that are used some outside the application inside the application itself. So the fact that core B is being consumed outside and core C is also being consumed outside means that they need to be extracted from the end user application. So we come up with a core application with the common services that are supporting both applications. And of course, I had to bring library B and C as well because those core B and core C, they depend on library B and C. So, and I don't want to have upward references. If I let library B on the end user application, it means that now I would also have an upward reference. So I end up having the correct application composition. And I will show you that discovery tool can help you on this process as well, or to find that you have a problem. Of course, conceptually, you should be able to design this correctly just by the fact that even in the first project, well, you don't need to worry about it in the first project because in the first project you packaged everything together, but at the minute you start reusing it, you need to isolate. The minute you start reusing it in another application, you need to isolate those core modules. Okay. Of course, strategically, you could started by isolating these in the first place because you know that I'm building something that is a core concept for this business that is highly reusable in the future, will be highly reusable in the future. So I could have started even in the first project by having two applications. But all I'm saying is that it's not very severe to start everything in one application because you can easily move. Refactoring the applications is cheap. You just need to move applications from one you just need to move modules from one application to another. Okay. Now, so this means that you also need to avoid upward references, side reference among orchestration and end user applications, avoid cycles to correctly layer up your applications. And you can use the discovery tool to find these violations and help you fix these problems. Another rule is that you should not mix owners. For instance, at a certain point, you have a common application with a lot of reusable components altogether, but they are being implemented by different teams with different responsibilities. And this is always a bad idea to have different owners on the same application, because every time you have to deploy this into production because module 3 changed, I need to put a new version, but I'm controlling the changes that I just made, and I know this needs to go to production, but then there are other changes being done, and it's out of my control, and so I don't know exactly what to do, and I might wrongly put something into production. So it's very important to promote ownership. So basically, the idea is to split these into different applications and clearly define the owners of each application in terms of development team. Okay. Finally, the last rule, it's similar to this one. This has to do with development owners, and the next rule is about sponsors or the business owners. Okay. So let's imagine that I have a simulation portal to simulate insurance in auto, life, or property line of business. And actually, I have different sponsors, different line of business. I have property business, auto business, life business. So if I do it all together, I lose the capacity to evolve the line of business separately, because this guy maybe has more money and he needs more features. He wants to enhance the property simulators, and he cannot wait for the others. Or maybe the auto is also enhancing it, but in the slow pace, and this needs to go faster. So I cannot have everything into a single application because I cannot have life cycle independence. So basically here, again, I had to split by business line, and of course, everything that is common, which is the portal above or the common services below. At least now I know what are the critical points, meaning that I can evolve these as long as I don't change the common service. I can place as many versions as I want for this line of business without impacting the others. And this might be a lot of restyling of the screens or whatever, so there's no influence. Only when you have to change some of the common service, then you know that you need to limit your, or to govern these changes globally. Okay, but you get much more life cycle independency among subparts of your original application. Okay, so I think I'm running out of time. And let me just, I'm almost done with this slide deck. Let me just revisit the example that we had before. Remember that we had this internal portal, supplier portal, the recall process, the supplier audit process, with all the elements that we identified before. Here again, in terms of application, instead of having only one application, I want to somehow isolate these two applications because they can evolve separately. And these are the common services that are reused by these two applications. Maybe in the future, they might be reused by a third and a fourth and a fifth application. So I'm collecting all the common services into a single application. Of course, this is simplified, and if you have different owners, you should split these. Or if you want to have different life cycles because something is evolving too fast here, but is at a different pace, and you need to control different versions for different parts of the system, then you need to split. So here we have the, well, this is the project integration service, which is isolated, can be reused by anyone in the future. The teams that are also isolated in our application because they can be reused by any other applications for internal user or for the supplier users. Of course, probably you will need to split these two in two because they relate to different areas. They might have different life cycles, just to illustrate that the application organization is important. If you look at the canvas, this is from Discovery. If you look at the canvas, you can easily spot what are the violations that you have. You can find out. And for instance, in this example, it becomes obvious that you don't have enough core applications, which typically means that the services are being provided everywhere on these on the end user modules, on end user applications. So this is an obvious sign that we need to analyze what is being consumed in these applications and extract new core applications. Okay. So if I look at this example, this is the same example that I have here. I can easily understand that, for instance, this guy is using something for the sales ERP is using something from above, so probably from one of these applications. I can immediately spot that this ERP suite, which is classified as an orchestration, is providing a lot of modules to the others. So I can start by looking at these and see that these are other applications consuming my modules, and I have all these modules being consumed. Of course, here I did not fix the module violations first, so I should not be consuming these. This means that, of course, I need to first fix these modules. They should not be providing services. But even I have the consumption of services here, but they should not belong to the ERP suite, because the ERP suite is the main application, and it's going to have a lot of end user modules inside, and these are reusable stuff. So I can actually find out what are the modules or what are the services that are being reused that I need to extract into another application, okay, or several applications. So this all depends on the consumers. If you have, for instance, if half of these modules are consumed by different applications from the other half, so there's probably a natural, conceptual split into subparts of your system. So this is all architectural considerations that you need to take into consideration. But the bottom line is with Discovery, so before I explain the module canvas, now I'm in the application canvas, you can easily find, for instance, if I want to see these violations, so it's consuming the sales ERP, and if you look what is being consumed inside sales ERP are all these modules. So you can either understand what am I exposing or what am I consuming that I should not be consuming in this case. For instance, you have here a cycle, so that means that the generic module is consuming this application inside is using the price manager. This one is consuming generic modules again, because inside is consuming these components. Obviously, these components, one of the directions is wrong. I mean, I could have this consuming this, but I cannot have that one consuming back the first one. So I need to figure out who is displaced here. So are all these generic? Maybe they are. So maybe the problem is on this side. Enterprise manager should not be on the system components. Okay, now you need to understand the nature of your modules, what are they providing. But normally there is a conceptual, acceptable relation. So if A consumes B and B consumes A back, you should know what is the natural, which one is providing more basic service than the other. So one is more high level because needs the second one, but you should not have both applications consuming each other. So bottom line, it's not a big deal to check your architecture and to understand if you're correctly abstracting all the concepts and correctly isolating your applications and act upon it, upon these findings. Okay, and this basically concludes my presentation. Let me resume the presentation. As a final reminder, so you need to keep in mind that you need to iterate your architecture, because architecture is a living thing. It's not something that you just design once and you don't worry about it. You need to keep avoiding the violations. You should follow patterns, and you should optimize application composition. All this presentation was built on top of these articles. How does OutSystems platform fit in enterprise architecture, in designing the architecture of your OutSystems applications? So you can follow these links to learn much more details, because of course I did not presented everything. For instance, there are just one section just to discuss style guides and how to share teams, different scenarios, or how to loosely couple modules, a bunch of other subjects. But the main objective of this webinar was to introduce the basic concepts, drive you to the correct direction, and then leave you these links to learn more. Okay?